Talking about Earth, we want to talk about the surface of the Earth and the interior of the Earth. We've talked a little bit about the interior structure. Let's talk about the crust, because that's the part we walk around on. That's the part that we live on. When we look at other worlds, that's the part that we see. We don't see the mantle or the core. We see the crust, the outermost part of it. And what goes on the inside affects what's going on the outside. So that's what we want to talk about. Earth's crust, the surface of the planet, the outermost part is of the solid part of a planet's surface is generically called the lithosphere. The lithosphere means the crust, the solid outermost part, and the uppermost part of the mantle that's also solid. The hydrosphere, that's the water on the Earth, the oceans, the rivers, the lakes, the clouds. That's all water and how that affects us. The atmosphere, that's what we breathe. That's the air around a planet. And Earth is the only planet in the solar system with a biosphere. That's the life that's on Earth. So let's focus first of all on the crust. All right. So when we talk about it, we talk about rocks and minerals. That's the solid things that make it up. Now, the definition here is a mineral is and a rock. Let's start with a rock. A rock is a solid, naturally occurring portion of the surface of a planet. So you go out, you pick up something that's part of the Earth that's a rock. Okay, that's simple. Now, the minerals are going to be like a rock. It's a naturally occurring solid, but it's all made of one chemical composition. So that would be, for example, like gold. That would be like quartz. That would be like ilmenite. That would be like ferrite. That would be a variety of minerals that are all made of one particular chemical composition. So that's the mineral. So it's kind of like a rock, except it's more restrictive. It's just one thing. The different kinds of minerals that you get because of different chemical compositions occur in different parts of the planet, depending on how the chemicals are distributed. So rocks really come in three different forms. We have igneous, sedimentary, and metamorphic. Igneous rocks are rocks that start off molten, material that starts off molten and then solidifies, and it makes a rock. Sedimentary rocks are rocks that are formed from pre-existing things. So you already have rocks and minerals out there, and you put them together to make a new rock. So sandstone, for example, you have sand, little tiny pieces, you put them together, and you make a rock that is sandstone. Or you have other sort of kinds of rocks in which you got minerals dissolved in water, and they evaporate the water and it leaves behind a deposit, a solid deposit. That'd be another way of making a rock, a sedimentary rock. Metamorphic rocks are rocks that, again, started off as some other form. They started off either igneous or sedimentary. And if you exert these rocks to very high temperatures, very high pressures, they can transform. They transform into another state. The crystals, the little solid pieces that make up the rocks, can move around. They can deform. You have chemical reactions that happen in there, and you change it from one type of rock to another type of rock. And so that'd be a metamorphic rock. Typically, in order to do that, you need extremely high temperature and extremely high pressure. Normally, not always, but normally that occurs deep underground, under the surface of the Earth. Remember, the farther inside the Earth you go, the higher the temperature and the higher the pressure. So metamorphic rocks don't normally occur at the surface of the Earth. So that means if you find one at the surface, something happened to bring it up from lower in the planet. Starting off talking about basalts and granites. These are two types of igneous rocks. One of the things I do when we're in person is I will bring in samples of rocks and say, here, here's samples of earth. Let's organize these or sort these out. One of the first things that you do is you say, well, here's a pile of rocks. Let's sort them in some fashion. And one of the most obvious ways of sorting them is to group them by color. We have dark colored rocks and light colored rocks. Unless you know any better, that's the first thing you do. And turns out that's exactly the right thing to do, because the dark colored rocks are darker in color because they have a little bit more iron in them. That makes them also higher density. The lighter colored rocks have less iron in them, they're lower density. The light colored rocks have more silica. That's silicon oxygen, silicon dioxide. So that silica comes in silicon dioxide in there. The darker colored rocks have less of it. So the family of dark colored rocks we often call basalts. And the family of light colored rocks we often call granites. So this gives us two basic categories of rocks. Now, it's not just basalt and granite. There's a whole bunch of rocks in the basalt family and a whole bunch of rocks in the granite family. One of the next big differences is crystal size. And you find basalt itself has very small crystals, and there's a similar rock called gabbro, which looks very similar but has very large crystals in it. Granite itself has large crystals, as in the picture you see the dark specks in there. But there's another rock called rhyolite, which has very small crystals, and they're very, they are very similar kinds of rocks, but they are slightly different. But they are in the similar family. What makes the rocks different here? Well, it's where they cool off. So you have magma. That's what you call this molten rock when it's underground, and it's working its way up here along fissures and cracks in the ground. And so sometimes it works its way off to the side and just gets trapped underground and solidifies under there. And sometimes it squirts itself out onto the surface and then solidifies. Now, if it works its way underground, squeezing between other rocks, we call those intrusive rocks. And if it extrudes out onto the surface, that's extrusive rocks. Well, two other terms we use for this. If they solidify underground, we call them plutonic rocks. And if they solidify on the surface, we call them volcanic rocks. And so here we have our two main categories of rocks here, basalt and granite, but they can be in different forms. A basalt rock that forms underground cools much more slowly than a basalt rock that forms on the surface. Likewise, a granite rock that cools underground cools more slowly than one that cools on the surface. Now, the slower the rock cools, then the more the chemicals diffuse and move around inside the rock. And like things tend to group together, and so crystals tend to grow bigger. So you get a rock, and each little crystal is going to be of the same kind or of a separate mineral. Whereas for a volcanic rock, it cools very, very quickly, and so you end up with little bitty crystals. They don't get a chance to grow very big. And so, for example, in my example before, basalt would be a volcanic rock or an extrusive rock, and gabbro, which is in the same family but with big crystals, is going to be an intrusive or a plutonic rock. It formed underground. Granite has big crystals. It is an intrusive or plutonic rock. It formed underground, whereas rhyolite, which is a similar kind of chemical composition, forms near the surface because it cools very, very rapidly and you don't get very big crystals. Now, the other thing that sometimes happens is you get gases dissolved in here. And so the gases can come out as well and make bubbles, or we call them vesicles, is the technical term for it, in the rocks. So famous for that would be scoria or pumice. And those would be two different types of rocks that are actually, they're so light because there's so many holes in them, air trapped in them. Often those rocks you can toss in the water and they will float. because of all the air trapped in them. And so all the gas is trapped in them, and so they're very low density rocks. Scoria is a dark colored rock, which is part of the basalt family, and pumice is a light colored rock, so it's part of the granite family. Both of those being vesicular type rocks. As the material comes out on the surface, you get volcanoes. Big piles of stuff. Now, the type of volcano you get is going to be very, very dependent on the kind of rock that comes out. If the rock is very thick and gooey and comes out, it's going to make kind of a plug and just gradually build up a volcano here. Very runny lava tends to spread out, and so you get a very flat volcano, what we call a shield volcano. If you have lots of bubbles in the gases that come out, it kind of throws little fire bombs up which fall down, and you build up what we call a cinder cone. And the cinder cone are big piles of these things, little smaller rocks that cool as they fall back down. And if liquid stuff comes up and hits and cools off, then that's a spatter cone. So it all depends. Turns out basalt type rock tends to be hotter and more runny. So a basalt type volcano typically is going to be a shield volcano. Whereas the granite type rocks tend to be more likely fall into the volcanic domes, or sometimes they alternate between being hot and cool coming out, so you end up with what we call a stratovolcano. So they're tallest volcanoes, and they're a combination of things that are coming out. What comes out and makes your volcanic mountain is very, very much dependent on what's underground, the conditions that are underground. So if you're looking at Mars or the Moon or Mercury or Venus and you see volcanic mountains, studying the structure of the mountain tells you a lot about what's underground. You can't really see what's underground, but you can figure it out from the type of volcano that you get.